Please pause the video and try this warm-up. Hopefully you noticed that the vertex, well, it's in vertex form, so 5, -3 is that vertex. The equation for the axis of symmetry then is x equals 5, because it's always that first number from our vertex. Domain will always be the same. It goes from -infinity to +infinity. And so without having graphed it, we can find the range because we know that we have a +2 for A. We know that the graph opens up. So that vertex is the lowest point. So that means that the y value on the vertex is going to be the lowest point that it can be. So that's why -3 is what starts it with a bracket because it's included and it's heading up towards +infinity. So today we're going to continue with the same section 3.1, quadratic functions. But our objectives today, we're going to determine the quadratic function's minimum or maximum value, and then we're going to solve problems using quadratic functions' minimum and maximum value. All right, so minimum and maximum values of quadratic functions. So once again, we want to consider our basic standard function f of x equals ax squared plus bx plus c. So 2 situations. 1, if a is greater than 0, then f has a minimum, because remember, if a is greater than 0, that means that the graph is going to open up. So that's why that vertex is the lowest point. So it's a minimum. And it's going to occur at the value x equals -b over 2a. So it occurs at the x value of our vertex. What the minimum value actually is, though, is the y value of the vertex, because it's f of -b over 2a. So essentially, you're substituting in the value of x into the function to find the minimum value, but it's occurring at the value for x. The second scenario is that if a is less than 0. So remember, if a is less than 0, a is a negative number. That means your graph is going to open up. So then that means that the f function has a maximum. And once again, it occurs at the x value, but the maximum value itself is the y value. So let's take a look at an example. It says, consider the quadratic function f of x equals 4x squared minus 16x plus 1,000. So without graphing, we're going to determine whether there is a minimum value or a maximum value. And so without graphing, what we need to know is, does the graph open up or does it open down? So remember, to determine that, we have to look at our a value. Well, our a value is in front of the x squared, and it looks like a is +4. So because our a value is a positive number, that means that our graph is going to be opening up. And so if our graph opens up, that means that our vertex is at the lowest point possible on our graph. And so that means that we have a minimum value. So then in part B, we're going to find this minimum value and determine where it occurs. So that means that I need to use that formula x equals -b over 2a. So I already know that a is 4. That means that the b value is whatever is connected to x. So that looks like -16. So I'm going to have x equals negative and then -16 divided by 2 times 4. So we really have then a +16 on the top. 2 times 4 is 8. So it looks like 2 is going to be where the the minimum value is at. So now we have to determine what it actually is, though. So I'm going to be substituting that number into my equation. So essentially, I'm finding f of 2. So I want 4 times 2 squared minus 16 times 2 plus 1,000. So when I plug that into my calculator, it turns out to give us 984. So essentially then, our minimum value is going to be that 984. And it's occurring when x is when x is 2. So here's my answer. And then in part C, it says identify the function's domain and range. So once again, domain is never going to change here. It's going to go from negative infinity to positive infinity because I can plug any value in for x and square it and get a real number. It's the range that's going to be different. And so because we're dealing with a minimum value, I know that the vertex is the lowest point. So range deals with the y values. So since my y value is essentially 984 at that vertex, that's going to be the smallest number. And so it's including it. So it starts at 984 and it's going to head up towards positive infinity. Okay, let's try another one. So we're going to consider this quadratic function, f of x equals negative 2x squared plus 4x plus 43. So once again, without graphing, we're going to determine if we have a minimum or a maximum. So I need to understand that my a value is a negative number. And so anytime I have a negative a, that tells me my graph is going to open down. So that means that my vertex is at the highest point possible. So that means this time we're going to have a maximum value. So now we're actually going to find this maximum value and determine where it occurs. So once again, I need to have that x equals negative b over 2a. So it looks like our b value is 12, our a value is negative 2. So we're going to have x equals negative, and then 12's in parentheses, divided by 2 times negative 2. So we'll then have negative 12 divided by negative 4. So it looks like positive 3 is where this maximum is going to be happening. So now I want to figure out what the maximum is. And so I'm essentially then evaluating f of 3. So we're going to have negative 2 times 3 squared plus 12 times 3 plus 43. So if I carefully evaluate that, looks like we're going to get 61. So it looks like then my maximum value equals 61. And this is at x equals 3. All right, and then finally we want to determine the domain and the range. Well, domain is just going to go from negative infinity to positive infinity, so it's the range we're looking at here. So because my graph is opening down, that means that it's heading towards all of those negative values. So I'm going to hit negative infinity, but then the highest it's going to go is my y value. My y value, the maximum, is at 61, and it's included, so there's a bracket there, and that's my range. Okay, so I would suggest that you pause the video and try this checkpoint problem. Okay, so hopefully we see that the graph opens down, so that means that we're going to have a maximum value. We are dealing with then negative 6 divided by 2 times negative 1 because our b value is 6 and our a value is negative 1. We get x to be 3. I substituted in 3 to get then my maximum value is negative 21, happening at x equals 3. So domain's always the same. The range, because it is opening down, it's going to hit all those negatives. The highest it's going to get is negative 21, which is included. All right, so let's talk about a strategy now for solving problems involving maximum or minimum quadratic functions. So we're going to read the problem carefully to determine which quantity is being maximized or minimized. We're going to use the conditions of the problems to express the quantity as a function in one variable. We'll rewrite our function into our standard form, f of x equals ax squared plus bx plus c. And then we'll start calculating. So just kind of like we did in the last problems, I know that negative b over 2a is going to be where this minimum or maximum is occurring. And then we'll actually figure out the value by then substituting it into the function itself. Okay, and then we'll just need to make sure that we're answering the question that's posed in the problem. Okay, so here's our first example. It says, among all pairs of numbers whose difference is 8, we want to find a pair whose product is as small as possible. What is the minimum product? All right, so we're talking about two different numbers. So that's why originally we're going to have two different variables representing each of those numbers. And we're talking about the product. So remember, the product, which I'm going to call P, is just multiplication. So I'm going to have one number be X and one number be Y. So here is my first equation representing the situation. So if I want to find the product of two numbers, it's X times Y. But then in the very first part of that sentence, it says that the numbers have a difference of 8. So when we're talking difference, we're talking about subtraction. So it doesn't really matter which one of those you put first. I'm just going to put X first. So I know that X minus Y equals 8. All right, so now that I have these two equations, it's kind of like a system, okay? I'm going to be doing substitution so I can then have all of my equation to one variable. So what I'm going to do is I'm going to actually manipulate this bottom equation here, and I'm going to get one variable by itself. So I think I'm going to solve for y. So if I want to solve for y, then I'm going to subtract the x, and then I'm going to divide everything by -1. So essentially, this is going to be the same thing as y equals. If I moved the x over, I subtracted, but then I'm dividing by a negative, so that's going to turn that x positive. Because the 8 starts as a positive, but I'm dividing by -1, it's going to turn to a -8. Okay, so now that I know that y is really the same thing as x minus 8, I'm going to go back to that top equation where the product is going to equal x times y. And I know what y is now. It's x minus 8. So now I have an equation where I can find the product with one variable. So I'm going to distribute the x, and so that gives me x squared minus 8x. And notice that even though there's no number at the end of that, I do have it into that standard form that it was talking about. So I have it into that form of ax squared plus bx plus c. And so now that I have that, I can identify my a and my b, so I can then use that formula of negative b over 2a to actually start solving for x. So in this problem, a is going to be +1 and b is going to be -8. So I get to solve for x by doing negative b over 2 times a. Well, back-to-back negatives makes that 8 positive. 1 times 2 is 2. So it looks like 8 is going to be 4. And so now that I know, or it's not 8, x is going to be 4. And so then I can find y by going back and saying, okay, that's 4 minus 8. I substituted that in. I got y to be -4. And so now that I know what x and y are, it's asking what is the minimum product. Well, product means I'm multiplying them. So 4 times -4 is going to give me my answer. So it looks like -16 is that answer. Okay, let's take a look at another example. It says you have 120 feet of fencing to enclose in a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Okay, we're talking area of a rectangle. So if I'm talking a rectangle, I know that opposite sides are congruent. So if I call one side x, I'm going to call the side adjacent to it y. And if I'm talking area, I know area is base times height, or length times width, or in this case, x times y. All right, so if they're giving me 120 feet of fencing to enclose this rectangular region, essentially what it's doing is it's giving me the perimeter. And so if I know one of my sides is x, so is the other. If one side is y, so is the other. So perimeter is us adding up all these pieces. So x plus x will have 2x, plus y times y will have 2y. So there's all four sides, and all four sides add up to this 120 feet. Okay, so here are my two equations. So once again, I want to set up now an equation where I just have one variable. So I'm going to manipulate the bottom equation here. I'm going to solve for y, and then that way I can then deal with an equation where everything's going to be in terms of x. Okay, so if I solve for y, I'm going to subtract the 2x over. So 2y is going to equal 120 minus 2x. I'll divide everything by 2. And so I know that y equals 60 minus x. So going back to that top equation, I know that my area is going to equal x times, and now I'm going to replace y with 60 minus x. Okay, I'm going to distribute to get it into that standard form that I'm looking for. So x times 60 is 60x, x times negative x is negative x squared. So this is in the standard quadratic form that I want. So I can identify a and b, so I can start solving for x. Now remember, a is the number that is attached to the x squared. The number that's in front of x squared is negative 1. B is the number that is attached to the x. Well, that's 60. So now that I know what a and b are, I can start solving for x. So we'll have negative b over 2 times a. So we'll have negative 60 divided by negative 2, and that's going to give me 30. So now that I have x to be 30, I can find y by substituting it back into the equation that y equals 60 minus x. So 60 minus then 30 tells us that y is also 30 in this case. Okay, so it says find the dimensions of the rectangle. So that means that I know that my length and my width are actually the same here. So I know that we're going to have 30 feet by 30 feet. And then if it's also asking what is the maximum area, well, maximum area is just multiplying those two together. So the maximum area is us taking 30 times 30. So that's going to give us 900. And then when we're talking units, we're taking feet times feet. So that gives me feet squared. So here are the three different things that the problem was asking for: length, width, maximum area. All right, let's take a look at this problem. It says you have 200 feet of fencing to enclose in a rectangular plot that borders on a river. You do not have to fence the side along the river. We're going to find the length and the width of the plot that will maximize the area. What is the largest area that can be enclosed? So notice that I already have a picture sketched for us. And so because we don't have to find all four sides, I called one side X. The other side across from it has to be X because a rectangle has opposite sides congruent. And then hopefully it makes sense that that third side is us taking the 200 feet and subtracting 2x from it. Because however long the x is, there's two of them. When I subtract 2x, it gives me the remaining length of that third side. So this diagram right here is going to help us set up our problem. Because if it's asking for us to find the largest area, well, once again, I know area is going to be us multiplying the two different sides of our rectangle together. And one side is x, and the other side is 200 minus 2x. So I'm going to distribute the x to find out that we really have an area of 200x minus 2x squared. And now that I have that, I can identify a and b, so I can start calculating what x is. So remember, x squared, the number in front is the a, so that's going to be negative 2. And then the number that's in front of b is 200, or in front of x is 200, that's b. So I know to start solving for x, I'm going to do negative b over 2 times a. So we'll have negative 200 divided by negative 4, and that's going to give me 50. Okay, so if it's asking for us to find the length and the width, well, that's going to be the width. So the width is going to be x, so it looks like we're talking feet, so it looks like the width is 50 feet. Okay, to find the length, I'm going to then substitute it in to that 200 minus 2x. Well, 2 times 50 is 100, so 200 minus 100 tells us that the length is 100 feet. And so then our maximum area is us multiplying those two things together. So that's going to give us 5,000, and then our units are going to be feet squared. And that gives us our answer. Okay, so I would suggest that you pause the video and try this checkpoint problem. Okay, so in this case, we did have to use all four sides. I know area is just length times width, so I just called one side of the rectangle x, one side y. I know that perimeter-wise, we have 50 yards, so I'm going to take 2x plus 2y, because there's two sides for x and there's two sides for y, and that has to equal 50. So I took that bottom equation, solved for y. So I subtracted 2x, divided everything by 2. I got y to be 25 minus x. So I'm going to substitute that value back into the area formula, and then that will give me an equation all in terms of x. So area is 25x minus x squared. That allows me to identify both a and b. I can then plug those into the negative b over 2a to find x to be 12.5 yards. That happens to then be the same exact value for the y. So that is both our length and our width. I multiplied those together, and don't forget that our area is going to be yards squared. All right, so that's us determining the quadratic function's minimum or maximum value and then using them to solve problems.